Hello children, welcome to aimsindia's online classes. So in today's class we are continuing the multiple choice questions from chapter Geometry. Coming to the first question for today, that is question number 19. Observe the given figure. What is the radius of a circle whose diameter is 14 centimeters? Now what are they saying here children? For the given circle, we already know that the diameter is equal to 14 centimeters. What is the diameter in this given figure? BC. Yes, both the endpoints are on the circle and it is passing through the center of the circle. So here the diameter BC is of length 14 centimeters. And then coming to the radius of the circle, D is already given. We have to find out the radius. Now if you remember from the class, what is the relationship between diameter and radius? We know that radius, when diameter is already known, radius is equal to diameter divided by 2. When diameter is already known, then the radius is equal to diameter divided by 2. Yes. So in this question, what is the diameter? 14 centimeters. So what will be the radius? 14 divided by 2. That is equal to 7 centimeters. Again in the question, the unit of measurement is centimeters. Diameter is given in centimeters. So the radius is also to be written in centimeters. Is this clear children? So what is our final answer for this question? 7 centimeters. That is option C. It is a very simple question. Diameter is already given and we have to find out the radius. So radius is equal to diameter divided by 2. That is nothing but 14. That is nothing but 14 divided by 2. That is equal to 7 centimeters. Now coming to question 20. The diameter of a circle is doubled. Now how does its radius change? Will the radius become triple? Triple means 3 times. Next, will the radius become half, or will the radius become the same or remains the same, or will the radius double? Now what is the question here? The diameter of a circle is doubled. Doubled means multiplied by 2. For example, if you take the previous question only, for example, the diameter was 14 centimeters and the radius was 7 centimeters. We found out. Now, if we double the diameter, that is 14 multiplied by 2 will be equal to 28 centimeters. Now, our new diameter is how much children? It is 28 centimeters. Now, what will be the radius for the diameter 28? Diameter is equal to 28. Radius is equal to diameter divided by 2. That is 28 divided by 2. When we divide, 2 ones are 2. When we subtract, 0 is remaining. 8 brought down. 2 fours are 8. When we subtract, 0 is our remainder. So what is the quotient here? The quotient is 14. That is nothing but radius is equal to 14 centimeters. Understood? What is our new radius? 14 centimeters. Radius is equal to 14 centimeters. Now if you compare the diameters and the radius. First the diameter was 14 and the radius was 7. Now what did we do? We multiplied the diameter by 2. When we multiplied, the diameter became 28 centimeters. Now what is our new radius? Our new radius is 14 centimeters. Now is this the same as the previous radius, or it is doubled, or is it triple? What happened here? Again, when we doubled the diameter, that is when we multiplied the diameter by 2, the radius also doubled. 7 into 2 is equal to 14. When the diameter of a circle is doubled, then the radius is also doubled. What did we prove from this? When the diameter doubles, the radius also doubles. Understood children? So like this, when you have such a question, what will be the correct answer? Option D, doubles. Doubles is nothing but multiplied by 2. So the radius and diameter, again if the diameter is tripled, that is multiplied by 3, then the radius will also be tripled. If the diameter is reduced by half, then the radius will also be reduced by half. So this is how we can prove that when a diameter of circle is doubled, the radius also doubles. Option. Next, question number 22. Arrange the shapes given in the following questions in their increasing size. Now this is very easy, right children? By just looking at the circles given, we can say that how to arrange. We have to arrange them in increasing size. That means the first one should be the smallest circle. Which is the smallest? B. So first comes B. Then we have the next circle is what? This one, C. Then the next one is D, and the last one, that is the largest circle here, is A. So this format B, C, D, A. B, C, D, A becomes the order of these shapes in their increasing size. B, C, D, A. I hope this is clear, and that is our option C. Increasing size. The smallest one is B and the largest one is A. Question 23. Which of the following is the net of a 6-faced cube? So what do we want here? We want a 6-faced cube. Net means when we, how do you say children? This is like a paper pattern. When we fold it, we should get a 6-faced cube. So first let us check whether all of these shapes here have nets. Nets have 6 faces or not? 1, 2, 3, 4, 5. It is having only 5. So A cannot be our answer. 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, so our answer will be either of these three. Either B, C or D. Either B, C or D. Yes, children? Yes. Now next we have to find out which exactly will become a 6-faced cube. What is the face here? Face is nothing but the surface, right? When you look at a cube like this, when you look at a cube, it will have 6 faces. Here 1, 2, up, below, side and back side. So all these will be 6 faces. Now from this, when you take the net in option B and when you fold it, then we will get a 6-faced cube, children. Okay, understood? You can also, what you can do is you can draw this pattern on a piece of paper, cut it and make folds along these lines. This, here, here. Understood? Make folds along the line and try folding it. It will come out in the shape of a cube. So option B is our correct answer. Question 24. Chandu is making spins using cardboard. He made wrong spins and only one. He made 3 wrong spins and only 1 correct spin. Find the correct one among the following spins. What is the spin? Spin is nothing but which will help us to, which will spin. Spin is like this, moving. For example, if you take the wheel children, okay, the wheel will spin, right? The wheel will spin, and also what else will spin? You have that cotton thread making machine. Yes, you might have seen Mahatma Gandhi sitting with that wheel. Again here it will spin. So for any object to spin, we have to make sure that the lines are in the middle. Understood? Even if you look at the wheel, the middle point will have a center point where all lines are connected like this. Yes, so it should be in the center point. Now from these given 4 spins, only D is having it in the center. So this will spin correctly. Now A, B and C, these 3 are the wrong spins. Okay children, only D will be the correct spin. Understood? So what is our answer? Don't go for option D, you have to go for option A, because option A has D as the spin here. So option A, that is spin number D, is our correct answer. Question 25. Circle is to radius such as cube is to dash. So what is this? We find the radius of a circle. Yes or no? Yes. So just like we find the radius of a circle, what do we find for a cube? Do we find the edge diameter circumference, or the correct answer will be edge. For the circle, this is the radius, right? So for a cube, what is the edge, children? This one, here, this line. Yes, these lines are nothing but the edges of the cube. Just as radius is to a circle, the edge and the cube also follow a similar relationship. Okay, so our answer is option A, edge. Now coming to question 26, an angle that is greater than 180 degrees but less than 360 degrees is known as a dash. It is greater than 180 degrees. Did we do angles, children? I don't know. See, 180 degrees, but it is greater than 180 degrees but less than 360 degrees. So here this will be a reflex angle. What will it be called as? Reflex angle. When an angle is 180 degrees, it will be called as a straight angle. When it is more than 180 degrees, it will be called as a reflex angle. When an angle is less than 90 degrees, it will be called as acute angle. And when it is greater than 90 degrees but less than 180 degrees, it will be called as an obtuse angle. Is that clear, children? Yes. So our correct answer for this is reflex angle. For example, this I have written it like this, right? Now this becomes the reflex angle. So when an angle is greater than 180 degrees but less than 360 degrees, it is known as a reflex angle. Now question 27, how many squares are there in the following picture? This is very easy, right? Just count the number of squares. 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just generally if you look at it, there are 16 squares. So keep 16 in mind, and then square number 17, square number 18, square number 19, square number 20. Clear, children? Now what is the total now? It is 20. And then again, if you look at the whole picture, this one, entire, yes, then we have 21 squares. And then again, if we look at it here in the middle, we have square number 22. So 22, and then where else do we have, children? Here 23, 24, 25, then we have 26. Is this clear? The total number of squares here are 26. So for this type of questions, you have to look at the given picture very carefully and try to find out as many figures as you can. So what is the correct answer for this question? 26. If you would have looked at just the picture casually, then you would have selected 16 as the answer. Now what is the correct answer here? 26. So option D, 26 becomes our correct answer. Now question 28. Some shapes can be fitted together edge to edge. This is called as option A, paper folding, option B, tiling, should not be here, option C, paper cutting, and option D, tangrams. So what is the correct answer here? Some shapes can be fitted together. We have learned in our class that, see, for example, if you look at this figure only here, yes, these shapes are fitted edge to edge. What is the edge? Edge is nothing but this one, the side, the lines. So side by side we have placed all these patterns or shapes side by side. So what is this called as? This is called as tilings or tessellations. Yes. So option B, tiling, becomes our correct answer. Now question 29. Which shape can be used to fill the pattern given below? Now if you look at the pattern here, children, this all we have to fill. So what shape can be used? Can we use a triangle, square, circle, or 1, 2, 3, 4, 5, 6, 7. So 7 is nothing but a octagon. Okay, this is a polygon. Let us just for now understand that it is a polygon. Now from these, which can be used? Just by looking we can say that it is option A, triangle. Yes, this shape here is similar to that of a triangle. So we can use our triangle to fill the given pattern. Question 30. Observe the picture given and answer the questions 30 and 31. Now in the picture, which number will be at the bottom? Now here, see, this is a cube and this one, let me take this. This one, the face at the top is 1, at the side is 2, at the front is 3. Understood, children? 1, 2, 3. Okay. Now at the bottom means here this, you can see slightly orange. Yes, this one, right? So at the bottom, which number can we find? Will we find 3, 4, 5 or 6? Now 3 is already given, so we can eliminate 3. So 3 cannot be our answer. Yes, so it's not 3. Now will it be 4, 5 or 6? See, while numbering the sides, we follow a pattern. We won't just number here and there. So when this is 1, 2, 3, the face at this side will be named 4 and at the back will be named 5 and the bottom face will get the number 6. The bottom face will get the number 6. Understood? See here, this side is 2. So then 3, then we have 4, then 5 will go at the back and at the bottom we'll have 6. It's like a round. It moves in rounds. See, 2, from 2 to 3, 3 to 4, 4 to 5 and 6 at the bottom. Is this clear, children? So which number will be at bottom? Option D, 6. Else, if you are confused as to which number will come, you can take the help of question number 31. What will the box look like if you opened it up? Just previously we had a question, right? Which net will make a cube? Yes, this one. So yes, so this is how the paper will look when we open the box. Yes, so even here they have given us the same thing. We are given a cube and when we open it, now from this which will be the correct one? Now here as you can see, the shapes of all of these are same. But what is the difference? The difference lies in the numbers. Now here in question 30, 1, 2 or 3, the numberings of 1, 2 and 3 are already given. So with the help of this 1, 2 and 3, by matching these we can find out the correct option here. See children, 1 and 3. So it should be in the same pattern. Okay, 1 if we take here in the middle, to the side we have 2. So this side will be having 2 and 3 comes below. So 3 will be here. So from the given options A, B, C and D, look which has the same as this one. When we come to option A, we are having 2 to the what side? Left side. But here we have 2 to the right. So A is wrong. Now B has 5 and 6 to the left and right of 1. But here we have 2 to the right of 1. So this is wrong. And then coming to option C, yes, we have 2 to the right of 1 and also we have 3 below 1. So option C becomes our correct answer. Okay, option C. When we open up this box, it will look like option C. Now as you know for sure that this is the numbering of the given box, with the help of these you can answer question 30 as well. See, will be at the bottom means which side? The side which is below 3. Yes, the side which comes after 3, below 3. Now from this figure, find out the side that will come below 3. This one. So what is the number? The number 6. So for question 30, the answer becomes option D, that is number 6. Is this clear, children? Yes. So if you are confused about question 30, with the help of question 31, you can solve question 30 as well. So for 30, D is the correct answer. For 31, C is our correct answer. Now next question 32. In the given figure, we have to find out A is the dash of the circle. Where is A? A is here. And A is a point. Now what point is it? Is it a radius, circumference, diameter or center? A is in the middle of the circle. So A is nothing but the center of the circle. Yes. So that is a correct answer. Question 33. What is B in the given picture? What is B here? What is B? B is showing as arrow mark. That means this entire circle, how much ever we are drawing, the perimeter of the circle. Do you remember the perimeter of shapes, children? What is the perimeter? Perimeter is nothing but the boundary. Along the boundary line, when we count the entire boundary, it will be the perimeter of the given figure. Yes. What is the area? Area is nothing but the area occupied inside. Yes or no? So here, even here, what are we talking about? We are talking about the perimeter of the circle. But in the options, we do not see perimeter. So what is this B? Perimeter of a circle has a special name, children, and that is nothing but circumference. For the perimeter of a circle, we do not call it as perimeter, but we call it as circumference. So B here is nothing but the circumference of the given circle, option B. Now dash passes A and its both ends lie on B. Passing through A. What is passing through A here? This one is passing through A and its both ends lie on B. This both ends lie on B. Here B is nothing but the circumference of the circle, right? This entire circle. Now what is this called as? Will this be called as the radius, circumference, diameter or center? Yes, it will be called as the diameter. What is the diameter of a circle? It passes through the center of the circle and its endpoints lie on the circle. Now question 35, children. The distance between the center and any point on the circle is called its. The distance between the center and any point on the circle. If we take it a circle, this is a center. From center to any point on the circle. What is this called as, children? It is called as the radius, right? So option A, radius will be our correct answer. Next question 36. The perimeter of a circle is called its dash. Now just now we have learned that perimeter of a circle has a special name. What is it? Is it radius, diameter, circumference or center? Yes, it is circumference. That is option C. So when you are talking about the circumference of the circle, it is nothing but the perimeter of the circle. This entire length of the boundary of the circle. Yes. So option C, circumference, becomes our correct answer. And question number 37. A rectangle has dash lines of symmetry. Now a rectangle. Let us draw a rectangle first. This is the rectangle. Now for this rectangle, how many lines of symmetry can we draw? This can be 1 and this can be 2. Do you remember what is the line of symmetry? Yes, line of symmetry is the line that divides the given figure into two exact halves. So for a rectangle, it has 1 and 2. Two lines of symmetry. That is option B. And coming to the last question for today, question number 38. Given below are three triangles with their length of sides. Choose the correct name for each triangle based on their sides. Now this, children, we haven't covered, but here let us learn about this topic. What is this? Now depending on the lengths of the sides of a triangle, we have different types of triangles. The first one is equilateral. Yes, just by the name we can say equi means equal. A triangle has three sides, right? So when all the three sides of a given triangle are equal, then we call it as an equilateral triangle. Now next, coming to isosceles triangle. Isosceles triangle is nothing but a triangle where two sides are equal and one side is different. Isosceles triangle is one where two sides are equal and one side is different. Now what can be the last one? The last type of triangle is scalene triangle. Now you can guess. Yes, in the first type we had all the three sides equal. In the second we had only two sides equal. Now in the third type, that is the scalene triangle, no side is equal. All the sides are different. All the sides of the triangle, that is all the three sides of a triangle, are different. So these are the three types, 1, 2, 3, depending on the lengths of the sides. Depending on the lengths of the sides, children. The lengths of the sides of a triangle, we can categorize triangles into three types: equilateral, isosceles and scalene triangles. Equilateral, three sides are equal. Isosceles, only two sides are equal. And the last one, no side is equal. All the three sides are different from one another. Now let us look at the given triangles. The first one, 3 centimeters, 3 centimeters, 3 centimeters. All the three sides here are equal. So what will it be called as? Equilateral triangle. Now coming to the second one, 3, 4, 1. Yes, 3 centimeters, 4 centimeters and 1 centimeter. All the three are different. So what will this be called as, children? Scalene triangle. Yes, all the three are different. And coming to the last one, 5 centimeters, 5 centimeters and 2 centimeters. Here two sides are equal. Only two sides are equal. So what will we call this type of a triangle? We'll call it as an isosceles triangle. So the third one is ISO. I'll write ISO here. Isosceles triangle. Now from the given options, we have to choose the one in the same order: equilateral, scalene and isosceles. So what is it? It is our option C, equilateral triangle, scalene triangle and isosceles triangle, children. With this, we've come to the end of today's class. I hope today's class was clear. We learned something new today. What was it? It is the types of triangle depending on the lengths of their sides. They are divided into three types: equilateral, scalene and. Visit our website www.aimstoday.in for other information regarding online classes, quizzes, live worksheets, DIY activities, English classes and coding. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.